Okay, so let's go. So what we are going to learn today is basically not too much but machine learning basic terms. This is a very important thing, by the way, because machine learning has some few terms which might look very confusing, and many people like don't know them especially, and like they get confused a lot because most YouTubers and courses in machine learning don't like use like let's say for example simple terms. They use very specific terms like hyperparameter, and then train, test, split, etc. So just keep in mind that I'm teaching important terms, by the way. So let's go here. So what I will do is just scroll up a bit. I'm now I will like divide it into two parts. One is parameter and another is hyperparameter. Most people use this hyperparameter or hyper-PM, whatever. So the fact is that most people use these two words interchangeably. That doesn't matter at all. But there is a significant difference between parameter and hyperparameter, especially in machine learning. So parameters are certain algorithms or properties which the model or ML model already already has and learns and changes. This what I'm trying to explain is that parameters are nothing but the types of properties that the ML or the machine learning model has, and which changes over time. I mean, like which changes over the process of learning. Learning. So they so whenever I talk about parameters, they include, let's say for example, weights and biases. Uh, I'm just asking you a question. Do you all know about weights and biases? You can either type yes or no. If yes, then I can like skip that part, and if no, then I will like explain it in 2 minutes. Prashanath, you don't know. Yes. Anyways, I will explain it. Don't worry, don't worry. So I'm going here. So weights and biases are nothing but parameters parameters that the model learns. So if you have done math, then you probably have seen this formula: y is equal to mx plus c. You must have seen this formula, right? This formula is very familiar. In machine learning also this exact formula is used, but here there is only one variable, that is x. X is only one variable. This thing is the predictor. I mean, like the predicted value. Like y will become whatever the m multiplied by x with addition to c will be. This is y. So in machine learning, you can use this formula also, but ideally we use y is equal to wx plus b. That means also we use this symbol y hat. Y hat means y is actual value in machine learning value. That means in a data set, there might be a data set like, let's say, study hours are and sleep 10 2 3 8 5 7, like this. So here you can see like, studying is a kind of dependent variable. So whatever the dependent variable is there, it's always x. And we consider it as x1 because there's only one x. And whatever is the independent variable or the this thing which changes with respect to this kind of thing, this is called as y, or the label or label. You can also call this dependent variable or x1 as parameter. So you might be confused like this parameter and this parameter in machine learning. So this parameter is a bit different. These are the properties of the ML model, but just remember that weights and biases are the parameters of the machine learning model, whereas x or dependent variables are the parameters of the data set. This is a data set. Here you can see like studying is a parameter and y is the label or this thing. There you can also call it as not predicted actually, like target. This is also referred to as target variable, this column where you try to like find. So basically the actual values are these things 2, 8 and 7 because these are actually in the data set. So they are 2, 8, 7. Now y hat is the values y hat, or you can also name it as y pred or whatever works. That doesn't really matter. This is just a naming convention. Are the predicted values. So this can be, wait, someone has joined. Amik or Ananya. Y hat or y pred is a predicted value. The model can predict it like anything at the first try. It can predict as 1, 2, 3, or it can also predict like or 2, 6, 9. It can also predict like this. Predicted value can be anything. Now what influences this thing is not the x thing, like not the x variable, but the things, this thing, weights and biases. That means that weights are the parameter that influence the prediction. It's multiplied by x, by the way. And bias is the additional number added to shift the prediction. Just remember this thing. Now, in a data set, you don't, this is just a demo data set. Like, there are two columns. One is the target, like the feature variable, and one is the target variable. But in real life scenarios, you have multiple things. Let's say, for example, for predicting, what should I say? Let me take a good example. House price. Yeah, I'm using a very beginner kind of thing. House price. You don't just like think of everything, like you don't just like check the size of the house and predict its price. You also check its like square feet. Let me just do one thing. Let me just erase this thing. Let me just name it a bit up. House price. So this is a data set. So here you don't just, there are not only one or two variables, there are many variables. And just remember that if there is only one feature column, then means that it's a one dimension data set. Just remember this. Now there are many other factors which the house price depends on, like square feet and bedroom number, like number of bedrooms, and then let's say what can I say, water facilities, tax, and finally the price. I'm just giving an example. So here you can like name anything, that doesn't matter. So which one do you think is the target column? Which one do you think is the target column to predict this kind of thing? The house price. Just yes, exactly. So this is price. So you basically take it as one dimensional array because it's only one. So it's price. And see, it has only one dimension, that is its rows and columns. So you take it as one dimensional array. Always remember that, in machine learning, y is mostly one dimensional. And now what is the dimension of this data set? What is the dimension of this data set? Just, you can also be wrong, it doesn't matter. I will correct you. Just try to like text or message here. What is the dimensionality or the whatever of the data set? Just try to message. You don't need to think much. You can just like give a brief guess. That doesn't matter too much because it's your first time like trying this thing, so you might be wrong also because I also wrong many times. Which one do you think? Exactly, Nuguri Rakshit. You are exactly correct. Because price is the y variable or target variable, and these are the x1, x2, x3, x4. So as I told you that number of x variables is the dimensions. So here are 4 x's, 1x, 2x, 3x, and 4x. So it is a 4-dimensional data set. If we take this as a target column. So basically that means that can you apply the standard wait, someone has joined. Pratik Jaiswal, you were a bit late, but that doesn't matter because I was just explaining a small thing. I hope you can like catch up to the like lecture soon. So I was basically explaining the I'm going a bit recap. Like I was explaining the hyperparameters and parameters. So parameters are basically weights and biases, where weights are the parameters that influence the prediction, and bias is the additional parameter that shifts the prediction. That's the main thing. And the data set, the thing which you are trying to predict is basically called as y, and this is the things which influence the prediction is called as x. And number of x variables are basically the dimensionality of the data set. And y is the actual value. Here, this is the y column, whatever you are wanting to target. So actual values are 2, 8, and 7. And the y hat or the y hat, this is the hat symbol, okay. This is the predicted value, which can be like 2, 6, 9, 1, 2, 3, or any kind of thing. That depends upon the model. And the weights and the biases directly. This influence. I hope you got it, Pratik Jaiswal. Now, this is just a simple like 2D, not 2D, like one-dimensional data set, but for house prediction in real life cases, you need many kinds of things like, square feet, bedroom size, water facilities, tax, and to calculate the price, this depends upon many factors. So you use the target column is of course, y column is of course the price, which is a one-dimensional array. Always it's a one-dimensional array. and the other things are x columns. Here many things influence, like x1, x2, x3. So this is the number of x is the dimension, so it's a 4-dimensional data set. I hope you got it, Pratik Jaswal. I just went a bit fast because I have to like go on. So now here we are, and let me just go here. So now here you can see. Now do you think that this formula wx plus b will be correct? If do you think this formula will actually work if I have so many numbers of x variables? Just type in a chat if you can. Do you think this simple formula of y is equal to wx plus b will work? Just like type in a chat. Do you think this will work? You can be wrong also, that doesn't matter. I'm ready to like correct it. Exactly, Nubir Rakshit, you are correct. So basically it will be y is equal to y hat, sorry, let me just cut this off, is equal to, now each column will be added to a separate weight. So this weight will go to this column w1, this weight will go to this column w2, this weight will go to this column w3, this weight will go to this column, and bias will be added here, and this will become the y prediction. So basically it will not be this formula. This is correct for only one dimension, but for many things you will use this formula basically. W1 x1 plus W2 x2 plus W3 x3 dot plus Wn xn xn plus b, where these are the number of things and weights are the number of additional parameters, and bias is only one in any kind of linear output. You just remember this. In neural networks the case is different because bias can take the shape of the output size, but for now it is only one in linear pass. So it will be exactly like this. But do you think, like let's say for example, do you think this formula will work when we have like 100 features? Let's say this is x1, this x2, and this goes on till x100. Do you think it will be efficient by just writing this formula manually? Like we will write everything like w1 x1, w2 x2, w3 x3 till w100 x100. Do you think this formula will look good or look more efficient or not? So what's the cheat code to like run this thing? Just you all like try to guess. It was from yesterday's lecture, by the way, and I forgot to mention it's that x can be like this. I'm just giving a brief hint. 1, 2, blah 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 blah, and weights are basically like this. Sorry, let me just. Weights are basically like this. Weights are basically one dimension, to be honest. 1, 2, 3. Let's say suppose the x has 3 columns and weight has sorry, weights aren't of this shape. I'm sorry, weights are like this, like one column and many rows. Like let's say there are 3 rows. So which one do you think will work? Let me just make it much more clear. There are 3 rows. Let's say for example 3 rows. This is row 0 to 0. Which one do you think will be more efficient instead of using this long formula? You will often find this in many theoretical math book because this is also correct, but this is too long in computation. This is correct mathematically, but there is a more efficient way to do it. So which one do you think will be good? Yesterday I taught you this thing, by the way. Use this as a hint. Wait, let me just check. Does weight in linear regression have only one column. A shape over weight matrix, yeah. It depends, but for linear regression, there is only one by one weight. And x to the 1. See, multiple features for multiple linear regression. That means there are multiple variables, 1, 2, and 3. So there is like, multiple features. That means the 3 features and the dimension, out dimension will be 1 output. Because in a multiple linear regression, you generally give 1 output because y is 1. See, n multiplied by 1. So weights is n multiplied by 1. That means n number of rows and 1 number of columns. So which operation will you think will be better in this thing instead of using this long formula for 100 rows or 100 data set, 100 dimensions? Just type in the chat. I want to know all of your answers. I taught you this topic exactly yesterday. Exactly, Inuguri Rakshit. Exactly. You are exactly correct, Inuguri Rakshit. Because, so basically, see, here you can see multiple features and one output. So X is basically in the form of, like number of columns. Here, let's say, suppose these are the 100 columns. 100 columns, these are X. And let's say, suppose there are, let's say, 4 rows. These are the 4 rows. So the shape of the X matrix will be in 4, 100. Now weights will be in the form of, always in the form of, when in a linear output, it will be in the form of 100, 1. So since the column of the first matrix, and the row of the second matrix is same, so we can, instead of using this long formula, we can directly apply the matrix multiplication algorithm or the operator, and this will be much more better. But to do this, see, here you are using w1 x1, w2 x2, w3 x3, etc. plus b. But in matrix multiplication, you don't use this. You use x at the rate w plus b. Got it? Because see, if they both multiply matrix, then the resulting shape will be 4, 1. And so the bias should also be 4, 1. 4, 1. It should also be like this. I hope you all got it. Is my explanation correct or understandable to you all? You can all type in the chat. Till where? Till where, man? Pratik Jaiswal. Which checkpoint? Okay, sure. So, whenever in large data set which has many columns, for this data set where you have 4 columns, you can directly apply this formula because you don't have to do much computation. But do you think writing... Oh, no problem, no problem. So, do you think for writing this formula is mathematically correct? But do you think will it be efficient if I write all the 100 things exactly at once and then multiply it by each weight using manual work, like using the right formula instead of using a simple algorithm? Because I have to type it so many times, y is equal to w1 x1, then w2 x2 plus w3 x3, then till w100 x100 plus another bias. Do you think this thing will be very convenient? Because I have to write in programming, I have to write it very, very long. Do you think, Pratik Jaiswal, it will be efficient? Because this formula is mathematically correct, but computationally it is very, very long if the data set becomes very, very large. Now I am giving you a hint. Okay, so x is the number of X is the shape of number of rows in a data set and number of columns in a data set. So this is the column, this is the column, this is the column, this is also a column, this is also a column. So now it's, let's say for example it has 4 rows and it has 100 columns. So it's in the form of 4 comma 100. Now the weight should be in the form of 100 comma 1, because here you can see multiple feet, not sorry, not here, here. Multiple integration, you have multiple features and one output. So basically the output will be 1, but the number of features are the number of columns, by the way. Features, input columns. So this is also taking the shape of a feature. So what operation do you think it will fit here? What operation can I add here, so that these two can add up very simply instead of using this long formula? In computation, what formula can you use in the center to like get the same exact output of the y? Pratik Jaiswal, just like try to recollect yesterday's session. I'm giving you a hint. These two are matching. The column of the first matrix and the row of the second matrix are matching. They are exactly the same. So what do you think will be, what thing can I apply here? Pratik Jaiswal. Yes, exactly. It's just like this. Yeah, exactly. You are very close to the answer, by the way. What operation can I apply here? What you said was conceptually correct. You are, yeah, exactly, matrix multiplication. So I have to apply matrix multiplication. So the resulting vector will take the shape of, like 4 comma 1, because it is like this. So the resulting vector will become 4 comma 1. This is the y. And you can also see, like, this is the resulting vector of this matrix. Always remember this. And you can see, whatever the case it is, the column of this thing is always 1. So it's a one-dimensional data. Y is always one-dimensional data. A number of rows can be anything. Now the main things which influence are weights and biases. So basically these things you don't make them on your own. Make them on your own. On your own. Your own. You don't do this. You don't do this. You instead tell the computer to learn. Tell the computer to learn. Computer to learn. To learn. Exactly. It's exactly like Gordian geometry formula. It's exactly. But the thing is that, when I have, like, one variable, then it becomes 1D. So I can visualize here only. Here like this. When it becomes, there are two vectors, like, x1 and x2, sorry, then it becomes 2D. So I can, like, show it like this. And when I have three variables, so x2, x3, so it becomes 3D. So it becomes like this, like, this thing, where this might go here also, like this. But when there are more than three x's, then the visualization becomes hard to visualize. Got it? So that's why we can only visualize a graph till the first 3 dimensions. But after the third dimension, the graphing or the visualization of the data set will be very, very hard, like almost not achievable, because we can only see till 3D, right? We can only see till 3D. 3x means 3D. We cannot see 4D. 4D is not visible to our eyes. I hope you understood, Pratik Jaiswal, what I was trying to say. Now, what now I'm going to be showing you is that, I'm showing the basic machine learning workflow with someone has joined. Why he, you can you can perform mathematical operations with 4D in computer, but you cannot visualize it. That's what I'm trying to say. Making is easy, visualizing is hard. Pratik Jaswal. Now let's take for example, I'm showing the basic thing. Okay. Now weights and biases are basically the parameters. These are the parameters which the method changes. There is also another additional parameter which I call it as dimensionality. It is, the number of columns. That's a parameter. The hyperparameters are the things which you make. Parameters are basically the things which the model tries to correct. And hyperparameters are the things which you set up. Set up explicitly. It can be, alpha. If you are present in yesterday's lecture, what is alpha? Just try to recall. You use alpha and LR. You set up the alpha and LR. The model does not set up the alpha and LR. You set up. But exactly, Nubri Rashid, you are exactly correct. So whatever the learning rate or alpha you set up, they are the hyperparameter. Hyperparameter is the thing which you set up in the machine learning process. Okay. Also, iteration or epoch. Epoch or iteration is also set up by you. Also, data split is also set up by you. So parameters are basically, in one sense, they are set up by model, and hyperparameters are set up by you or the user. I hope you all understood this concept right. There are many other examples, but that would be too much, and that's not the scope of the lecture. So I hope you understood the basic idea of these things and the dimensionality of a data set. I hope you understood. You all can type in the chat. Okay, now I will show you. Now there's another kind of thing. Okay, it's the cost function, or you can also call it as loss function. So this is nothing but the method for calculating error. Oh, sorry. I by mistakenly clicked on undo. Method of calculating error. Now see, suppose you scored, out of there's full marks is 100, but out of here you only scored around, let's say, 60 marks. So your errors will be 100 minus 60, which is equal to 40 marks. Am I right? So this entire thing which you are using, it is the nothing but example or a demo of a cost function. Exactly. Now see, when I this now the errors I made is 40. So this is very big. That means I made big means more error. And suppose now to improve it, I must like learn from it. Pratik Jaiswal, yeah, you are correct. Exactly, exactly. I must learn from it. Of course, I must improve it. Then in the next test, I got out of 100, I got, let's say for around, I got, I got 92. That's a very big jump, by the way. So my loss cost function is, almost like 8. So now comparing 40 with 8, you get 40 is more than 8. So that means that I made more error in the first exam. And less error in the second exam. That's the main thing. And basically I learned from it. So like iteration can be like iteration in this real life example can be iteration can be like you know um learning like books, class test class test school test school test, etc. And learning rate or alpha can be as what to say attention span. It's just a basic example, you don't need to take it seriously. That's the main thing. Now for here, we don't we don't actually use a very simple formula. We use many functions. Some are like MSE, mean squared error, where I'm not showing the mathematical formula. I will show the mathematical formula. Okay, 1 by m, where m is the number of features. This I guess n is equal to 1, I is equal to 1, like this something. Then y hat minus y. That means the actual value minus this thing and whole square, because mean square error. See, because I'm summing up the entire things and I'm squaring it, and the number of features I have is the mean. So basically I'm doing it like this, y minus y, it can be anything, by m, and I'm just squaring it. That's the main thing, y hat minus y. You can also do it like or you can do it like y minus y hat. That's also the same, because squaring it like makes it positive, makes the error positive. It makes it positive. That's it. But always remember that, and there is also another term which is called as hypothesis. Hypothesis, thesis, or pass. You usually use hypothesis function. So hypothesis is basically whatever your algorithm the model is learning. Like for example h of x, or you can also write it as or y is equal to x at the rate w plus p. That's a function. Hypothesis can also be the 1 by 1 minus e means Euler's number, by the way. X, it can also be this, it can be anything. It's just a thing. Now see, what are those? Why did it show some number? This is exact. What are those? Pratik Jaswal, sorry for replying late, by the way. These are nothing but cost function. You got it? This, whatever you are saying, is the cost function or the loss, which you try to like find out. Sorry if I'm replying late, by the way. Now, basic ML workflow. Let me just show you the basic. Basic means I'm not sure telling about basic machine learning. I'm just telling that how normally machine learning workflows work. Workflow. So that you all better understand, because I will, of course, that's a great question, by the way, Pratik Jaswal. So basically, I put the predicted value. So basically, I put the basic predicted value. Let's say, for suppose, loss. You, in loss, always remember, you always put the y predicted and the y actual y value. Here is equal to any kind of thing. Let's say y hat minus y whole square by 2. It can also be. You just use this thing. That doesn't matter actually. You just use the function, put the y hat and y variables, and the function calculates it. I will be showing you. Okay, no need to worry about this. Basic ML workflow means that you first initialize weights. Not initialize weights, by the way. Let me just go from a straight main step. You first take clean split data. By splitting, I mean, splitting is basically training. Splitting is basically you divide your data into train and testing sets. Training means which you use to train the model. Train the model. Testing means which you test on it. That's it. Suppose if this is a data set, if this is a thing, let's just make it. These are the things. X2, X3, and there are 10 columns. 10 columns. Not 10 columns, sorry, 10 rows. 10 rows. Then, if you make the train test split, if you make the test size means that basically the percentage of testing data is 0.2. 0.2 basically is 20%. 20 by 100 or is equal to 20%. That means that I'm using the 20% of this thing, the bottom portion. That means the 9 and 10th, because these are 2 and this is the 8. So I'm basically using the upper 8 as training data, and the lower portion as testing data. Just remember this data. You can set up the ratios whatever you want in training testing, but ideally, basically, mostly the ratios is either 70:30 or 80:20, where this is the train and this is the test. You can also type in Google actually. Most common ratio of train test split. 80 by 20. See, 80 by 20, and here also 80 by 20. 80 is 20, whatever. You can set up whatever you want, but ideally 70 or 30 or 80 by 20. We also make this thing and 90 by 10 for large data set. Ratios. I hope you understood train test split, right? I'm just explaining it on the side. I'm not teaching all things blindly. I'm trying to explain each and every topic which I speak out of the mouth. You first take split data. This is the data processing stage, data pre-processing stage, processing stage. Sorry. Let me just erase it. Sure, sure. I will record each and every session. You don't need to worry. Like yesterday's session was recorded and I will post it probably today. So no need to worry. You can check whatever you want. But we have a lot of the session. I suggest you like skip some parts and look at the most important parts only in the video. Got it? Prashant Nath. Because this like our cohort is not like strict machine learning, but we also have like friendly chats, solving doubts with each other, etc. So that might eat up some like 10 to 20 minutes. So I hope you like adjust the time, adjust the video, whatever. So this stage is called as data pre-processing. Processing. This is the first stage. These are basically the same. This is the first stage. And now you have the now you initialize weight and biases. This modeling. This is one stage. Whatever I'm saying might not be the exact true definition in many cases, because in some cases this might be modeling, this some cases this might be data pre-processing. That might like interchange a lot in many videos and textbooks. So I'm just showing my way, okay? Because many people have their own ways, but basically the workflow is exactly the same. The names are a bit different in many other cases, but basically they are all the same. Now you run through this thing at a y is equal to this. This is called as pass or hypothesis function. Hypothesis function where you try to predict, where the model tries to initially predict the value. Now, do you think the first prediction of the model will be correct? Just try to like give in the chat. Just try to like write in the chat if possible. Do you think the first prediction of the model will be correct? Because the initial weights and biases are basically either random or zeros or ones. Not at all. It is never correct at all. So if it is not correct, what you do is you use. Now what do you use to check if it is if how much not correct is it? What do you use to check? What do you basically use to check if the model is not correct? Like the quantitative measure. Just like type in the chat, that might work. No. Inuguri Rakshit, you don't check the weights. Weights aren't checked. Weights are learned. Just remember this. What do you check? What thing you use to like check number of errors made by the model? This is the first pass. This might not be correct. So I must you have a certain kind of algorithm or thing to like check if how much error it has done. So what should I use? Inuguri Rakshit, Pratik Jaswal, Aditi Mahadik. If you all can answer, even if it's not correct, it would be like appreciable. Exactly, Pratik Jaswal. No, Inuguri Rakshit. Never. Because you don't check the data set. You just check the data set whenever you are comparing the model with testing data. Got it? Whenever a model passes any kind of wrong thing, you use not this thing, but this thing. Wait, where was it? Where was it? Where was I gone? Where was I gone? Where was I gone? Where is it? You use Where was I? You use this thing, cost function or loss function, whatever what you want to calculate, because it is a method for calculating error. So let's take for example, I'm just showing this thing. So example, actual y can be 1, 2, 3, and 4, and y model might predict it as 0 0.2, 9, 10, 1. So you use to essentially calculate the error made by this, to essentially compare and calculate the errors between these two things. You use cost function, and always remember that cost function returns a scalar. Scalar means a single number. Let me show you. Does cost function return a scalar? I might be wrong also, because mostly it returns scalar, but it there are some exceptions. Yeah, it always returns a scalar, single scalar value. Example 15.4, etc. Just remember this. So now it can be like, loss bracket y comma y hat is equal to whatever blah blah blah. There can be any loss function. It's not like, I will use only this mean squared error or something. I will not only use this formula. There are many other things. I can use also log loss, which I will be teaching if time permits. Now basically what you do is the cost function. Now you try to find the derivatives. Now there is a concept called partial derivative where you use del. That's not d, it's del. Del is like this, like a curved 6, like a reversed 6 or a mirrored 6. Del loss function, del loss, because it's a function, and if it has any kind of weights, then you use del by, then you try to find a derivative. It's called as the error calculation. Fine. With this pen is a bit thin. Fine. Slash differentiate the function of error. So now you might be thinking now we basically use this thing, partial derivative of del loss with respect to del weight and del loss with respect to del of bias. Now you might be thinking where did weights and bias come, right? Am I right? You all might be thinking where did weights and bias comes? Because in loss you always calculate y and y hat things. Why? How did weights and bias come? Are you all confused? Just tell me. It's very normal to be confused. It's not a bad thing actually. Now you can see let me just scroll a bit up. Y is basically the same. Now let me just go here. So y hat is equal to this. It can be anything, but I'm using linear formula. Okay. Now can you see there are weights and biases? Can you see here? Y hat. Everyone just comment. And let's take it as this. Now can I substitute the value of y hat into the loss function so that I can so now I can also make it y hat, considering y hat as, let's take for example y hat, since y hat equal to w 1 x1 plus w2 x2. For simplicity, let's take w1 x1 plus b. Let's take for just simplicity, we will take this thing. Got it? W1 x1 plus b. So you can also write it as y hat is equal to wx plus b, wx plus b. I'm just using for simplicity. For many variables also there is the same thing, but the the differentiation will look very lengthy, so I'm not showing this. I'm using only one x. So instead of writing wait, let me just go here. Instead of writing y hat, can I write it as wx plus b? Can I write this? Because I substitute a value, both are exactly the same. I'm just using y hat for a shorter notation. Is it correct? Everyone try to like chat or give a message. Haha. So I can also use it like y minus, or let's me just erase it, w1 x1 plus, not w1 x1, it will look very confusing right now, wx plus b minus y whole square, because I substituted the value, because see y hat is equal to wx plus b, and if I put here, initially it was y hat minus y, but I substituted the value, so it can be also like this by n. Now you can see it is so much clear where the weights are, where the biases are. Now can you now is it making sense why I use this del loss by del with respect to del weight and del loss with respect to del bias? Did you all get the understanding? Just type. If you have any kind of confusion, I can explain it to you. I have no problem in that. You all can just type. Exactly, Nuguri Rakshit. You can use any kind of formula. Y sometimes also as, y is equal to 1 by e to the power x. That's also something. For here, the differentiation will be different. Yes, we're going to explain once again weights and bias. What do you want to do? Pratik Jaiswal, I don't understand your question. Do you want me to explain this thing or the definition of weights and bias? Which one do you want, Pratik Jaiswal? Okay. Sure. So let's take, for example, this is a data set. This is the y or the target variable. This is 1, 2, 3, and 4. And here are, just move here. And x can be 2, 4, 6, 8, 9, 10, 1, 2, 3. Now to make this into this variable, I need some parameters, right? These cannot be directly made into this thing. Pratik Jaiswal understood. So what I will use is weights and biases Suppose, let me give you a simple definition. What can I say? Let's take a simple, I'm taking scalar value, okay. 4, and here it is w times, where I'm taking x is equal to 0.5, w bracket 0.5 plus b is equal to 4. Now to in usually machine learning, the algorithm goes like this: x remains the same, w first becomes strong, 0.2, 0.5 plus b 12, let's say for example, is something blah blah blah. Now you compare this thing. Now if I try to like make, now once I reach a certain number of iteration or trial and error, then I will get, where W can be like, let's say for example 6 bracket 0.5 plus bias can be 1 is equal to 4. Now 6.01, 6 multiplied 0.5 is 3 plus 1 is equal to 4. So not the weights and biases are nothing but which influence the target or the Y prediction. So whatever the Y pred is there, it will always be influenced by this thing and this thing. Got it? Weights and biases. X remains the same in the machine learning workflow. X is always same, but the thing which changes are weights and biases. Did you get it, Pratik Jaiswal? Just simply remember that weights and biases are the things which the machine learning model learns in order to like predict some output or result. Now let me just cut this off. I actually, thanks man, thanks. I actually like the way you are asking doubts. Like, I'm literally surprised that, in one side there are people who like aren't even replying in the group chat, and I remove them by the way, and there are some people who are asking me doubts and I'm ready to explain them. Like that is very like, motivating. Thank you all, man. Thank you, Pratik, and everyone. Literally everyone. Like whoever joined this cohort online sessions. And Pratik, I've like not seen you absent. Like you may be absent for like one day or so, but I've seen you consistently. So yeah, I really appreciate that and you asking doubts. So I'm always ready to help you in the near future also. We can work together or like we can do some collaborative work if needed to. Even if like our age gaps are very different, but whatever the fact, we can like always learn from each other, right? Sure, sure, man, Pratik Jaswal. Always grateful. So now what you do is, see, w at x plus b. Now what you do is, you try to partial derivative this thing. You derive this thing with respect to w and derive the loss function with respect to b. Now I won't be teaching, I don't use CapCut. Oh, in the this thing here. Oh, here you are saying, right? In the here. I just downloaded it using some kind of VPN from the official website, of course, using VPN so that I don't get caught. Okay, okay, okay. Nah, just use some kind of no, VPN, whatever you have, and then like go to CapCut official website and download it. That's it. Now let me go to the thing. Now, see, once you have calculated the this thing, differentiated. Now, the differentiation of this thing will, let's take for example, the differentiated W will be differentiated underscore W, and this thing will be differentiated underscore bias. This is not a function, this is just a variable. Now what you do is, now you set up the weights. Now you set up now this d by loss with respect to d by this thing weight is equal to, so it's underscore d underscore w, and d this thing d by bias is equal to d underscore bias. So these are the variables you get. These are derivatives which you obtain. Now what you do is, now you set up the hyperparameter in a loop. First you initialize the learning rate or alpha, whatever alpha, and epoch. you set up these things, learning rate or alpha and epoch. Now what will happen is that now this entire thing, let me just use this thing, this entire thing, let me just zoom it out, is a loop. Now what you do is, now the loop will repeat. It will repeat till the number of epochs or iterations. The repetition of loop is measured by its epoch or iteration. Got it? Now what will happen is, you will use just this simple formula. Weight is equal to, because since variables can be overwritten, variables can be overwritten, written. So you will just simply write it as weight minus, see, alpha multiplied by this thing, what to say, derivative of weight, and bias is equal to bias minus alpha, which is learning rate, multiplied by derivative of bias. This is underscore, okay, this is not a negative sign, this is a minus sign, but this is a underscore. Now see, now you might understand here, now, let me see. Suppose the initial weights were 10 and the bias was 15. Now the learning rate I take for, suppose, LR is equal to 1 or alpha. Let's say for example I take alpha is equal to 1 or whatever. And I found that the derivative of weight was around 2. And derivative of bias was around, let's say, 1. So basically what happened was that, let me just make it like, this was 1, derivative of bias was is equal to 2. So basically what I do is, like, these are the initial. Now once I run a loop, so the weights will be like, 10 minus alpha multiplied by 1 multiplied by 1, which is equal to 9. This is the first iteration, first epoch. Let me just use epoch. Now again the weight will become like, then now in the second loop it will become 9, because the updated weight is 9. So now the derivative of weight and bias remain the same, and the alpha also remains the same. Now it will become 1 multiplied by 1 again, because alpha multiplied derivative of weight is of course 1, so it will become 8. Until then it will reach in the nth iteration or epoch as, let's say, negative 15 minus 1 times 1 is equal to negative 16. So at the end of the loop I'll get this. Same for bias also. Got it? Now this will become the updated weight, that the model will finally use, and it will predict a somewhat correct output. I hope you understood. Now what you do is, that's it. This is the entire loop. I hope you all understood the loop, right? In the first iteration or epoch, if I like make the if I take epoch as epoch is equal to 20, let's say, for suppose, then it's the first epoch, and the 20th epoch it will become negative 16 or something. So this is the updated weight. The end of the epoch, there is a final kind of result of the weight or bias. That's the updated weight and bias, which will be used to predict the next output, and it might be correct or may not be correct. Now basically you now get the updated weight. Now you get the weight. This is the updated one. Updated, updated. And also you get bias is equal to updated, dated. This can be anything, like 0.2 or equal to 2.1. And now the model might, like, suppose, let's take a data set. If this is like x1 is 1, 2, and 3, and x2 is 3, 4, 6, and y is equal to 10, 9, 12, then the weight may not be, the model might almost like predict with the updated weights. It might like updated weights, okay, these are not the initial weights, these are the final weights or the updated weights. After the model learns, they will be like around 9.2. I'm talking about the y vector, okay, this thing 10.1, 11.9, like this. They will be close to this prediction, like actual value, but they won't be exactly the actual value. I will tell you the reason in the next class. So this is the entire machine learning workflow. Now you just try this on new testing data and then you validate it. So basically, what's the basic ML workflow? You first, wait, let me just use that color. You first initialize the data. You take the data, you clean it, you spot on the missing values, and you split the data. Then the training and testing splits. This stage is known as the data processing stage. Now you make a model where you use a function, initialize the weights and biases. This is the modeling stage. Now this is also a modeling stage. These are also the same thing, modeling stage, but I'm separating them for better understandability. Now y head is equal to, it can be anything. Hypothesis function, you pass it. Now hypothesis function might give a wrong output, so you now use the error calculation to like calculate the error. It returns to scalar. So now you differentiate with function with respect to weights and variables, the error function. Now you use this thing. Now then since after you find the derivatives, you pass it through a for loop where the number of loop it is the epoch, and it learns through a kind of learning rate. And once the derivatives are calculated, then it becomes like this. It's the weight thing. Okay, I'm just showing it in a visual manner. It may not be correct in the syntax, but I'm showing in a visual manner. 10, it becomes like this. It goes and goes till the last epoch, and now the updated weights are here. Now what you do is the final updated weights become this and this and this, and bias also becomes this. And now you like pass it again with a kind of function, and you check whether they are matching with the data set or not. They might not exactly match with the data set. They will be like, but very close to the data set. This 9.2 is close to 10 almost. 10.1 is almost close to 9. 12 is almost close to 11.9. So it will be like this. So this is the entire thing of machine learning workflow. I hope you understood. This is the end of the lecture.